So you hear the term AI thrown around all the time, right? But what does it actually mean? Well, today we're going to cut through all that noise. We're going to understand the technology that's already changing our world, from the phone in your hand to, well, our collective future. Let's dive in.
You might think AI is some far-off sci-fi concept, but guess what? You're already using it. Every single day. I mean, every time you ask Siri for the weather, or when Netflix just knows what movie you want to watch next. Even when Google Maps finds you that sneaky shortcut to beat traffic, that's all powerful AI working behind the scenes. It's not coming, it's already here.
All right, so here's our game plan. We'll start with the AI that's literally in your pocket. Then we'll get into how these things actually learn from data. From there, we'll explore the three main ways they do it, take a peek inside an artificial brain, and finally check out the super exciting creative AIs that everyone's talking about.
Okay, first up, AI in your pocket. Before we go any further, let's get a really clear, simple definition of what we're even talking about.
So what is artificial intelligence? At its core, it's just technology that lets a computer do things that normally you'd think only a human could do. You know, things like spotting a pattern, understanding what you're saying, or even analyzing an image, like reading a license plate from a grainy security camera. If it feels like a human-level task, that's a pretty good sign AI is involved.
Now, this is super important to get straight. Think of AI as the whole donut. It's the big, overarching idea. Now, a huge chunk of that donut, the part where almost all the action is today, is machine learning. And then, a smaller, super-powered piece of machine learning is called deep learning. So honestly, when you hear people in the news talking about AI breakthroughs, 9 times out of 10, they're really talking about machine learning.
And that leads us perfectly into our second section, learning from data. Because this is the fundamental shift, the game-changing idea that makes modern AI so incredibly powerful.
Okay, get ready, because this right here is the big aha moment. For decades, with traditional programming, a human had to sit down and write every single rule. We gave the computer our input and the logic, and it spit out an answer. Machine learning completely flips that on its head. Now we give the computer the input and the final answer we want, and we tell it, you figure out the rules. It literally teaches itself the logic.
So how does that actually work? Let's use a bank as an example. It's a two-step process. First, training. We feed an AI model a mountain of historical data, say thousands of old loan applications and whether they were ultimately approved or rejected. The machine just churns through all of it, learning the hidden patterns. Then comes step 2, inference. Now when a brand new application comes in, the model uses that logic it learned to predict the outcome. That's the core loop. Train, then predict.
So now that we know that machines learn, the next question is how? That brings us to section 3. We're going to break down the 3 main training methods that power pretty much all of modern AI.
First on the list is supervised learning. And honestly, the best way to think about this is like a student studying for a huge exam, but they have the answer key. The machine is given a ton of data that's already been labeled with the right answers, and it just studies those examples to figure out the patterns. The perfect everyday example? Your email spam filter. It was trained on millions upon millions of emails that real people had already marked as either spam or not spam. By seeing all those labeled examples, it learned what spam looks like so it can protect your inbox. Okay, next up, let's take away the answer key. This is unsupervised learning. Here, there are no labels. We just give the machine a gigantic, messy pile of data and basically say, find something interesting in here. It's like dumping a huge box of mixed-up Legos on the floor and asking it to sort them into logical groups without any instructions.
A great real-world example is how a news website might group its articles. The AI scans thousands of stories and just starts to notice patterns. It sees that articles with words like touchdown and quarterback are similar, and articles with election and Senate are similar. It creates the categories, sports, politics, all by itself just by finding those hidden connections.
And the third main type is reinforcement learning. This one's a bit different. Here you have an AI agent that learns by doing things. It learns through pure trial and error. It takes an action, and based on the outcome, it gets a reward or a penalty. It's a lot like how you train a pet.
Yeah, think about training a dog. Good boy, you get a treat. Bad boy, no treat. It's the same idea. An AI playing a game will try a move. If its score goes up, that's a reward. It'll try to do more of that. If its score goes down, that's a penalty. After millions of attempts, its whole goal becomes just to get the most rewards possible.
Okay, so we've covered the what and the how of learning. Now we're going to go a level deeper and peek inside the brain of the operation. This is where we get into deep learning and the amazing tech called neural networks.
So the engine that drives deep learning is something called a neural network. And yes, it's very much inspired by the actual structure of the human brain, with all its interconnected neurons. These things are absolute beasts at finding super complex patterns in messy, real-world data like images, sound, and video.
To wrap our heads around this, let's just forget about AI for a second and think about something we all understand, calculating a final grade in school, right? You have your inputs, your scores on different tests. Each of those inputs has a weight or an importance. Your final exam is worth a lot more than a pop quiz. And then you combine all those weighted scores to get your output, the final grade. Simple enough.
Okay, you with me? Because a neural network does almost the exact same thing, just on a massive scale. It takes in inputs, like all the pixels in a photo. It assigns a weight or importance to each one, and then makes a guess. But here's the absolute magic. If it gets the guess wrong, it goes back and adjusts all those weights just a tiny, tiny bit and tries again. It does this over and over, millions, sometimes billions of times, until its guesses get incredibly accurate. It literally learns from its mistakes.
And all of that incredible learning power has led to something you've definitely been seeing everywhere lately. So for Section 5, it's time to meet the new kid on the block, generative AI. So what's the big deal with generative AI? Well, almost everything we've talked about so far has been about analyzing data or predicting an outcome. Gen AI, well, it creates. It generates brand new, completely original stuff. Text, images, music, even video, all from just a simple prompt from a human. And I know you've heard of these tools. For writing text, you've got ChatGPT and Gemini. For creating unbelievable images, there's Midjourney and DALL-E. We're even seeing mind-blowing video from tools like Sora, and for coders, GitHub Copilot can write code for you. This is the creative frontier.
And that brings us to our final section, our final stop on this tour, our AI future. After all this, let's zoom out and think about the big takeaway here. Look, we've built machines that can learn, that can predict, and now that can create. We've gone from the AI in our pocket to AIs that are like artists. Understanding the how is absolutely crucial, but it's not the biggest question anymore. The real question, the one that's going to define the next chapter for all of us, isn't a technical one. It's a human one. How are we going to work with them? What do we want to build?